Hello everyone. Class 12th, chapter number 5, lecture number 1, homework solution. So today I'm going to give you some solutions of homework questions of exercise 5.1. Let us start with the very first question. It is question number 3, D part. So here the function is given as f of x equals modulus of x minus 5. Let us break the modulus and write the values of function. Now, when you write the answer inside the modulus, you may get the positive or negative answer as well, right? So break this modulus sign, we're getting positive and negative answers, right? So positive answers you're going to get when your x is greater than 5 or equals 5, right? And less than 5, if value of x is less than 5, you're going to get the answer as a negative, right? This can also be written as 5 minus x when we solve. So now let us see what are the cases that can be formed here. We have to check the continuity of this function at x equals 5, x less than 5 and x greater than 5. Let us go with the first case, which is at x equals 5. So f of 5, as you can check, will be 5 minus 5, which is 0. Now let us solve our LHL, that means left hand limit. In that limit, x will tend to 5 minus a value which is very smaller than, like very slightly lower than 5. The function for less than 5, as you can see, is 5 minus x. So the function will be 5 minus x. Changing it to h tending to 0. 5 minus. Instead of x, we are going to write 5 minus h. Now solving it and putting the value of h as 0, we get the answer as 0. Let us solve our RHL. In that you will write limit x tending to 5 plus, right, and the function, as you can see, for 5 plus we have what function? This one, x minus 5. So the function will be x minus 5. Changing it to limit h tending to 0. What do we get? Instead of x, we are going to write 5 plus h minus 5. Solving this, we get the answer as 0. Now I can see that f of 5 and your limit x tending to 5, f of x. So I see these are equal. All the three things are equal: LHL, RHL, and value of the function at that particular point. Clear? Hence the function is a continuous function at x equals 5. Now see for x less than 5, the second case of it. Okay, now when we check for the second case of it, just to see x less than 5, if we take for x less than 5, the function is going to remain as 5 minus x. Let us solve that on a different sheet. So second case is that x is less than 5. For x less than 5, the function is 5 minus x. Correct? As you can see here, for x less than 5, what is the function? 5 minus x, and this is the second case. Let us solve it. So for less than 5, there are so many numbers, right? So we can just take any number c which is less than 5, because there are so many numbers. Also we see less than 5, the LHL and RHL function will have the same value as 5 minus x, and we can also say that this is a polynomial function, hence this will be continuous. We can directly write it that it is a polynomial function and it is continuous. Similarly, for the third case, okay, which is x greater than 5, the function is x minus 5 there. It is also a polynomial function and it will be continuous, because at every value of x it is defined. There is no value of x that we place here in the functions and can say that the value of the function is not existing or not defined. So I'm just giving you example for the second part how you actually write it. You will write let c be any number which is less than 5. Correct? So you are going to check at c. C plus and C minus. Just check f of c. So you check f of c, that will become as 5 minus c. Now you have to check it c plus and c minus. Okay, and check whether the function values are equal or not, whether the limit exists or not, whether LHL, RHL and value of the function at that point c is equal or not. And then you can say that the function is continuous. Otherwise, for polynomial function, we can write down that being a polynomial function, it is going to be continuous. There is no value of x that makes it not defined. Let us go to the next question now. Here comes the next question. Now, as you can see in this function, they have defined for x less than equal to 2 and x greater than equal to 2. The function value is defined to us. Now, what do we have to check? Find the point of discontinuity of f, where f is defined by this. Now, first one, we have to check x less than 2. Second, we have to check for x greater than 2. And the third one, we have to check at 2. Correct. Now see, some of the students get confused when I say x less than 2 or I say that x is tending to 2 minus. Right? There is a huge difference between the two things. X less than 2 means you are going to check for all the real numbers that are less than 2, whether the function is continuous or not. When we say x is tending to 2 minus, that means here x value is slightly less than 2. It is a very close value to 2, but it is less than 2. Right? Similarly for x greater than 2. So don't just say that we are checking at x equal to 2, 2 plus 2 minus, and we have checked the function. No, for x less than 2 all the real numbers, and for x greater than 2 all the real numbers which are greater than 2. You have to tell whether the function would be continuous or not. Like at x equal to 2, you are going to check f of 2. As you can see, equal to sign here, right? So function is 2x plus 3. Instead of x, you have to place 2. So 2 plus 2 into 2 is 4 plus 3. The answer is 7. Now you are going to check LHL. Limit your x will tend to 2 minus, right? Less than 2, we have to take 2x plus 3. Okay, now you will write it as limit h tending to 0. Instead of x, you are going to write 2 minus h plus 3. So when you solve and place the value of h as 0, you get the answer as 7 again. Okay, this is LHL. Now if I check RHL, just to see, you will write limit x tending to 2 plus. The function, as you can see, for greater than 2 is 2x minus 3. Right? Now limit h tending to 0, and instead of x you are going to write 2 minus h minus 3. Now let us solve it. When you solve it, you will write, put the value of h as 0. So 2 2s are 4, 4 minus 3. What do you get? 1 is the answer. So you see, the function value and LHL value is same, but the RHL value is a different number, which is 1. So the function is only left continuous. I can't say the function is continuous all over. So at point 2, for the third case, you will say the function is discontinuous. So one point of discontinuity that we had to calculate is 2. Now less than 2 and greater than 2. Less than 2, the same function you are going to operate with 2x plus 3, as it is a polynomial function. It will be continuous all the values which are less than 2. Same, x greater than 2, the function will remain as 2x minus 3. In LHL and RHL, it is not going to be changed. So we say for less than 2 and greater than 2, the function is going to be continuous for all real numbers, but for 2, the function is not continuous. Hence the point of discontinuity for this function is 2. Clear? Let us now just move to the next question. Okay, I just wanted to show you this. In this question number 9, in this question, first of all, we will check at x equals 0, then at x less than 0, and then at x greater than 0. So these will be the three things we're going to check. Right? Now see, at x equals 0. What is f of 0? it is given to us when x is equal to 0, the value of the function is -1. So we are going to check now LHL. Okay, let us solve it in a different column. So I am solving LHL. Limit x tending to 0 minus. For 0 minus, I can see the function is x upon mod x. Changing it to h, instead of x, I am going to write 0 minus h upon in modulus 0 minus h. When I solve it, we get minus h upon h, which is minus of 1. Correct? So minus 1 is the answer here. Minus 1 is the answer here. Now let us solve our RHL. Clear? So in RHL, just to see, okay, limit x tending to, what should I write now? 0 plus. The function for greater than 0 is -1. Right? So the answer will be -1. So I see at 0 the function is continuous. Clear? So I hope this is clear. And we see LHL, RHL and value of the function at that particular point is equal. So the function is a continuous function at 0. Now at less than 0 and at greater than 0 are the two different cases that we are going to check on. Let us check that. So I'm taking a new sheet on which I'm going to explain the next cases. Suppose we take now x less than 0. For x less than 0, I see the case is x upon modulus of x. Let us write that in the next slide. So when x is less than 0, our function that to be taken is x upon modulus of x. Let us just recheck it. See, x less than 0, we have x upon modulus of x. Okay, now let us check it. Let C be any number. Okay, so you just have to check it C. So f of C will be C upon modulus of C. So you know when x is less than 0, it is going to be a negative number, right? So we will break this mode. When x is 0, less than 0, so it will be right x upon minus x. That gives the answer as -1. Hence, in C plus and C minus, it is going to remain same. So the function is a continuous function in this case, right? Similarly, you can check for x greater than 0. For x greater than 0, you will have x upon modulus of x. So you are going to get 1 as the answer. Just to see whether LHL, RHL and the function value at that particular point is same or not. Let us go with the another question now. Here comes the another question. It is same as the question that we have just discussed. So wanted to give you a hint only at 2. At less than 2 and at greater than 2, you're going to check the function continuity, right? The point you feel like, suppose at 2 you're getting LHL and RHL different, you say 2 is the point of discontinuity of that function. Clear? You may get the values less than 2 also at which the function may be continuous, greater than 2 that you have to check and show. Let us just discuss this last question where it is saying is the function defined by this is continuous or not. So first of all, you're going to check at 1. Let us check at 1 first. At x equals 1. So I'm giving you the complete solution, right? The complete one, the way of writing in this question. You can follow this for all the questions. So at x equals 1, this is the first case. F of 1 will be, I see equal sign here. So f of 1 will be 1 plus 5, which is 6. Now I will solve LHL, where I'll write limit x tending to 1 minus. For less than 1, the function is x plus 5, okay, which will be written as limit, changing it to h tending to 0. I get instead of x as 1 minus h plus 5. Putting the value of h as 0, I get the answer as 6. Now, let us move to the another question or the another part of this. RHL we are going to solve. In RHL, I will write limit x tending to 1 plus. For 1 plus I see the function is x minus 5. So limit h tending to 0, instead of x we will write 1 plus h minus 5. Putting the value of h as 0, we get the answer 1 minus 5 is minus 4. So you see the function is not continuous at x equal to 1 because the RHL value is not same as the value of the function at that point and LHL. Hence the point of discontinuity is 1 here. Clear? So here they are just asking, is the function defined by f of x is a continuous function? So we got one point where it is not continuous. We can say here no, it is not a continuous function. So you write like this: value of function at 1, okay, is equal to limit x tending to 1 minus f of x does not equal to limit x tending to 1 plus f of x. Or we can just say that the limit for the function does not exist, which means the function is not a continuous function. So this is all for your homework part. Thanks, and in the next lecture we are going to discuss the other questions of the same exercise, as it has 34 or 35 questions, right? So that's all for today. Thank you. Bye.